This unit, Introduction to Critical Environments and Biocontainment, is the first unit of biohazardous risk reduction training. It introduces the design and mechanical features necessary for safety in facilities dealing primarily with biohazardous situations. Of course, you've worked and you understand your job and you understand the systems and the features of the facilities that you'll be working with. This training is not intended to teach you that. It's intended to teach you how to use those systems and those mechanical features in high containment, or a synonym for that is critical environment, to keep yourself safe, to keep the facility safe, and to keep the public safe. Microbes or agents are any bacteria or virus or toxin that is worked on in a lab. Another term that you could use would be microorganism. Beyond those microbes, though, anything living is a biological, and it's the harmful byproduct of those biologicals that are biohazards. So you'll see this symbol. It's the universal symbol for biohazards in many different places within a facility. Sometimes on the lab door, indicating there are unsafe things within. Sometimes it'll be on the trash bag that's even set in the hall. A select agent is a very dangerous microbe or a toxin. And select agents are determined by the Center for Disease Control and the USDA. They're determined as select agents, and they fall under a lot of regulation because they have the potential to pose a severe threat to public health of both humans and animals. They're regulated so heavily that just a very few individuals are approved to handle them. The primary challenges working with microbes are contamination and aerosols. So we work on them in rooms that we call critical environments. The critical word is not about the room, but about the work we're doing and the microbes we're using. The way we handle that challenge is by containing those microbes or the contamination or the aerosol. And we do that either structurally by isolating that room, or mechanically with airflow, and sometimes with personal safety equipment. If a lab is being used on pathogenic microbes, then that lab is termed hot. People who work in those labs are specially trained and use special personal protective equipment. Extending the concept of critical environments just a bit, there are 4 levels of labs in which microbes are worked on, the level being determined by the biohazardous danger of the particular microbe. Much of the rest of this whole unit will be spent discussing the specifics of those 4 levels. To give you an overview of safety levels of labs, the next few slides will be the interior pictures of BSL 1 through BSL 4 labs. and then I'll describe the design and mechanical features. This is a picture of a BSL-1 lab, but to be honest, a BSL-1 lab is just about like your kitchen. It has a door for access of control. It has a sink for hand washing. All the furniture in that room and in your kitchen are easily cleanable. It has normal construction, no unusual ventilation, no unusual floors, does not need to be separated from other rooms. Any safety that's needed in your kitchen is the same type of safety that's needed in this lab, and vice versa. Anything they do in that lab, you would be able to do in your kitchen. But that's the type of lab that's considered a BSL-1. This is a picture of a BSL-2 lab. A good example of a BSL-2 would be a doctor's office or a hospital lab. All of these labs, all of these areas are designed with different microorganisms in mind. Those microorganisms used in BSL-2 labs may be pathogenic, but they definitely have cures or good treatments. So, like a BSL-1 lab, this lab is the same but has a few more mechanical features. It is separated from the public. It has controlled access. That means that either the door is going to be locked, well, the door will be locked, but you can either get in with a key code or a card. Sometimes you have to buzz in. The ventilation in these labs can be different. Doesn't have to be. There is an area over here on the left of this picture. It's called a biosafety cabinet. It keeps the materials from being aerosolized out into the room. It's away from the doorway. And there is an autoclave available. This is a picture of a BSL-3 lab. The mechanical features of these rooms is stepped up quite a bit beyond those of a BSL-2. That's because the primary goal of this level of containment is keeping aerosols from spreading. If you remember, the primary route of contamination is by aerosolization of microorganisms. The microorganisms used in these labs will definitely cause disease and illness, but there are treatments for them. Those mechanical features used in BSL-3 labs include they must be in an isolated zone of the building. These labs must be isolated. They must have a restricted entry. That means biometrics or the pin pad. They must have inward flow of air. That means the air is always coming into the room. The air in the room cannot leave the room and get out into the building. That's one facet of the control of aerosols. The air that leaves the room is single pass. That means it's not taken back into the air conditioning system and used in the other areas of the building. It leaves this lab and goes out into the environment, usually after it's filtered. These labs must have interlocking, self-closing doors. That means once you enter the lab, the door closes behind you, and it must be closed before the next door will open. All of the room penetrations in these rooms have to be sealed. That means all of the electrical outlets where the walls join the floors and the ceilings must be sealed. The ceilings can't be drop ceilings unless they're hard dropped. They have to be sealed floors and ceilings. All the work done in these labs, all the work is done in a biosafety cabinet. There's nothing on an open bench. And these rooms have pass-through autoclaves for sterilizing the items and specimens that are used inside. Often Working in a BSL-3 requires extra safety equipment, a total body Tyvek, that's the type of material. It looks like a worker's overalls, and sometimes a PAPR, that's their respiratory system, must be used. Here's a simple quiz. Look at this image of a typical lab. It's a little old, but it's a good lab. Think about, according to what we've just discussed, BSL-3 interiors and how they need to be contained, how they need to contain aerosols. Look at this image and determine what's wrong and what's right. The answers are on the next slide. This is a picture of the interior of a BSL-4 lab. BSL-4 is where the very most serious organisms are used. Those are the organisms, the microorganisms, that if you become infected with them, there is no cure and no treatment. They are very likely to be lethal. So, the people working in these labs, you can see in the picture, they have many layers of safety protection on. That safety protection is called personal protective equipment, PPE. The air they breathe is, you see the little wires, the little tubes coming into their outfits? That's air being pumped in from another source outside the room. These uniforms they're wearing are all sealed. They are airtight. All the air that they have comes in and goes out there. It is impermeable to liquids. So these people are wearing extra safety protection, and they're practicing with extra safety procedures. The mechanical features and the design features of these labs are increased. And the reason I would go through that with you is not that you'd ever work in here, but these rooms are not rooms you would accidentally walk into. They are deep within a building, isolated, and you can't just walk into them. There are many rooms that you have to walk through to get into these rooms, ante-rooms and preparation rooms. So we'll go through some of the mechanical features unique to these. Going into them, you have to take off all of your street clothes and put on these outfits. They're Tyveks with the PAPRs. When you leave these rooms, of course you have to take those outfits off, but you also have to shower out. So it takes a lot of time to come into and out of these rooms. All the waste that's generated in these rooms has to be decontaminated. So again, the autoclaves in these rooms have to be passed through. They put all the waste in on one side, it's autoclaved, sterilized, and removed on the other side, safe. All of the air, all of the water coming into these rooms and out of these rooms has to be specially filtered. The filter is called a HEPA filter, but that's a very intense filtration system. And these rooms have to have backup power. So, if there's an emergency and the building loses power, the air conditioning and the ventilation of these rooms will not escape into the rest of the building. You and the public will be safe. Most work done in a BSL-4 is done in a contained glove box. The image on the top right is a good image of a glove box. It just shows how there is, there are actually gloves in the sash of the safety cabinet, and you need to reach through those to manipulate the items inside. It's not open in any way. Obviously, the gentleman standing here is not working in a BSL-4 because, as in the picture below, people who work in BSL-4s have to be in complete containment type suits. Those are like space suits. The air that they are breathing is coming through the red hoses and it goes into the suit. So there's not the PAPR unit on their back that you would use in a BSL-3. Think about this with me. If you're going to work on the air handling unit or on the boiler that is used by a BSL-4, you cannot enter that area easily. So some, not all, but frequently, you'll find the mechanical systems of a BSL-4 separated from the BSL-4. In this image, the air handling units are on the top of the building, probably the top 2 floors, and the boilers are underneath the lab. This chart is a summary of the different biosafety level lab features that we've been discussing. You'll see a general description of those levels and a sample organism or disease, and then what that really, the effect those organisms or diseases have on us. If you're doing the skills training portion of this training, there will be much more discussion about all of this, including the mechanical features needed to meet those requirements. To this point, we've been talking about biosafety levels as if only human pathogens were the specimens. The case is, though, often animals, insects are worked on in different BSL-3 labs, so these have different names, and they're listed for you here. With a capital A before the BSL-3, those are small animals, rodents, rats, mice. If the abbreviation AG is after BSL-3, that indicates large animals are being worked on in those labs. So many different mechanical features and specifications need to be brought into those labs. Vivariums, those are areas where insects are worked on. So you can imagine the precautions taken to keep the insects with the disease inside the lab. But there are other rooms. Clean rooms are different. Clean rooms have air flow that is moving out of the room to protect the sterile areas in the room from contamination. That's the exact opposite of a BSL-3. BSL-3, the air moves into the room, keeping the contamination in the room. Clean rooms, air moves out of the room, keeping the room sterile. We've talked about the safety features of different BSL levels of labs, but the entire building and grounds are also designed in ways to help contain microbes. This is done by creating zones of containment or isolation, and they're called, interestingly enough, primary, secondary, and tertiary barriers. So if we look at this diagram of concentric circles, primary containment is down at the bottom. Primary containment is the type of containment created or designed to keep the scientist and the microbes separate from the rest of the room. An example of that would be the biosafety cabinet. All the work done in these labs is done in a biosafety cabinet. Secondary containment is between the microbes and the building. So that example would be like a suite of labs. Those labs are going to be separate from the conference rooms, the break rooms, the offices. And then the tertiary containment is going to be a separation between the microbes and the outside world. Now, most facilities, most buildings that BSL-3 and 4 labs are in are going to be pretty stark looking on the outside. There's not going to be a lot of landscape. The lawns are either going to be paved or minimal grass. That's to keep insects and pests down to a minimum and to be able to spot guests quickly. Parking lots are going to be removed. Those are examples of tertiary containment.